Before data can be stored and indexed in a vector database, it is split into smaller and more manageable chunks. This improves the embedding quality and therefore the retrieval quality of the data. There are a few popular techniques for chunking, which can be used depending upon the structure of the data and the use case. Fixed size chunking is a technique where text is split into chunks of fixed token or character length. This method is simple and easy to implement, but as you can imagine, it can break sentences or ideas midway. Therefore, an overlap of tokens is maintained between consecutive chunks. This helps preserve context across boundaries. Typical chunk sizes range anywhere from 200 to 1000 tokens, and the recommended overlap is 10 to 20% of the chunk size. In this example, we have a chunk size of 300 tokens and an overlap of 50 tokens. So, how can you pick an ideal chunk size? Both small and large chunk sizes have their own pros and cons. Smaller chunks perform well for granular searches that involve specific facts or numbers, but they lack surrounding context, which is needed for tasks such as summarization or how do I do this kind of questions. Larger chunks, on the other hand, provide surrounding context, but they can introduce noise as a chunk can contain multiple topics. They can also increase cost due to larger prompt length that is sent to the large language models. Anywhere from 250 to 500 tokens is typically a sweet spot for chunk size. This range offers a good balance of context and retrieval speed, and therefore it's a good place to start experimenting. Recursive chunking is another technique for documents that have a structure. It provides an upgrade over fixed size chunking as it fits the chunks in a size limit but does not break sentences or meaning midway. The system maintains a prioritized list of separators, and the process begins by splitting the text at big boundaries like sections or headings. This is done by looking at the separator characters that are on the top of priority list. If the chunk is too big to fit the size limit, it is further split into paragraphs, and if a paragraph is still too long, it is further split into sentences. This process avoids breaking sentences or ideas midway, and you can further improve continuity by introducing an overlap between consecutive chunks. Hierarchical chunking is another technique for structured documents. In this technique, a parent child hierarchy is maintained to ensure that responses can include both detailed as well as high level information. At the time of chunking, the system parses documents, sections, subsections, and paragraphs to create an explicit tree like structure to preserve the parent child hierarchy. During retrieval, first the smaller chunks are identified based on semantic similarity, and then looking at the tree hierarchy, parent sections are added for well contextualized results. This is especially useful for documents where structure carries a meaning, such as manual, reports, and legal documents, and where providing surrounding context with the retrieved chunks can add value. The three techniques that we have seen so far split the text based on structure. Semantic chunking goes a step further by grouping the text based on meaning rather than structure. Chunks are formed by detecting topic shifts in the documents to ensure that each chunk represents a coherent concept. Typically, a sentence level embedding model or a large language model are used to detect topic changes in documents. This technique is a good fit for messy data such as chat logs, transcripts, or notes where text lacks structure. In order to decide the right chunking strategy for your use case, you need to observe your document structures, your query styles, and latency and complexity requirements. Fixed chunking or recursive chunking are easy to implement and inexpensive to index. Many production retrieval augmented generation systems start with these techniques as a default and then iterate from there. Semantic and hierarchical chunking are computationally expensive and they introduce additional metadata overhead. Therefore, they are best suited for high value use cases or when simpler approaches fail to deliver. Whichever chunking strategy you pick, you must evaluate responses using a sample query dataset. You should run automated A B tests and also have human validation.